Hey there, math scholars. I thought I would record a video 6:45 a.m. here, just in case I don't make it through the school day. My daughter was up last night. She was very sick, and I'm afraid that I might be coming down with it too. So hopefully I make it through the school day and you don't need to watch this video. But if you do watch the video, it's going to be a very, very short crash course on stem and leaf plots and histograms. I want to start with bar graphs versus histograms with you guys. Here it is. A bar graph and a histogram look similar. They've got those bars going up, but it's the categories that set them apart. A bar graph would have categories with words such as comedies, actions, romance, etc. And a histogram would have more of a range of values. So they would count up the numbers between 60 and 65 and chart that amount, and count up the numbers between 65 and 70 and chart that. So that's the main differences between bar graph and histogram, and I believe it said we're going to be doing histograms today. All right, let's start with a stem and leaf plot. It's a data display that organizes data based on digits. It kind of like cuts numbers in half. So for example, like the number 34, I remember it because stem and leaf make me think of a tree, and a tree makes me think of a chainsaw. So you'll literally chainsaw this number in half. You'll separate the 3 from the 4. The 3 will become your stem, and the 4 will be your leaf. So that's the first number on the stem and leaf plot. You can see the 3 is the stem, the 4 is the leaf. So I will read off the numbers in this data set. It'd be 34, 36, 38, 38, 40, 43, 46, 47, 47, 50, 50, 51, and 52. And you can find mode really easily by looking at the number that occurs most often. This data set has 3 modes, 38, 47, and 50. You can find the mean and the median just like you always have, and same with range. Okay? That's how stem and leaf plots work. They don't have to always cut the number straight in half like we cut the 34 in half. They could cut decimals in half. Let's say we have got 7.2. They could actually cut the 7.2 in half. So here's just a few examples of things they cut in half. Let's start at the top. 6, they could actually make it the number 0, 6. 47, they could make 4 and 7, separate them. 710, they could actually separate that 1's digit off. And 8,802, they could separate the 1 digit off. So it's really up to you and your data set and how you would set up your stem and leaf plot. Alright, so let's make a quick stem and leaf plot for this data set. You make a T-chart. You'd write stem on the left and leaf on the right. And then you just glance down through. It looks like my smallest values are in the 50s and my largest values are in the 80s. So maybe I'll make stems of 5, 6, 7, and 8. So we got 65, 72, 52, 84, 66, 82, 57, 66, 58, 80. I'm going to squeeze the 0 in here. I do want my leaves in order. That's what I'm attempting to do. 62, 59, and 52. So I did my best job at leaving myself space so I could get those leaves in order from smallest to largest. But go ahead and click pause if I didn't give you enough time to complete that stem and leaf plot on your own. Alright. Oh, I do want to point out what a double stem and leaf plot looks like. It's very strange, but they actually have the leaves, the stems in a center column. So let me kind of explain. This is Olympic gymnast ages back in 2004, but basically there'd be a 16-year-old on the women's team, another 16-year-old, an 18-year-old, an 18-year-old, a 25-year-old, and a 26-year-old. And now the men's team, you read it backwards. So the stem is still the same stem. Like this 2 is the stem. The 7 is now the leaf, even though it's over here on the right. That is awkward. So 27 years old would be a man, 24-year-old, 23-year-old, 21-year-old, 21-year-old, and 30-year-old. That's kind of how you interpret that. So if you would need to compare the ages, I'd say the men's team is much, much older They don't have any teenagers, and they even have a 30-year-old on their team. All right, so that's a double stem and leaf plot. I saw one of those on the air test, either last year or the year before. It says the frequency of an interval is the number of data values in that interval. Here's an example of a frequency table. So it kind of just says different prices and how often it occurs. So there are, looks like 4, kind of blurry, 4 sandwiches in the $4 to $4.49 category, 2 sandwiches in the $4.50 to $4.99 category, none in the $5 to $5.49 category, and then 4 in the $5.50 to $5.99 category. Okay. A histogram is a bar graph that displays data from a frequency table. Each bar would represent an interval, and because intervals have equal size, the bars would have equal width. A bar's length indicates the frequency, and there's no space between the bars. I almost want to go back to the warm-up real quick. You don't have to write this definition down. It's a very lengthy definition, but just be aware of what they look like. So let me go back to my warm-up slide here. See how the histogram, the bars have no space between them? That's something I forgot to mention when we were looking at it. It's because like they touch 60 to 65, that interval touches the interval 65 to 70, right? Let's jump ahead. It says the number of song requests per day for a 2-week period at a radio station are shown below. Let's make a histogram of the data. All right, so first things first, on the homework tonight, they give you this data in a stem and leaf plot, which is no problem. Our data's on a list, but you're gonna have to come up with like different ranges. The best ranges to use would probably be tens intervals, like 0 to 10, 10 to 20, 20 to 30, and maybe even organizing in a stem and leaf plot is the best way to organize and see what you're dealing with as far as your frequencies. Let's go ahead and make a stem and leaf plot. All right, so 12, we would go ahead and separate. 1 would become our stem, 2 would become our leaf. 22, we'd go 2, 2. 18, 1, 8. 26 would be a 2 and a 6. We've got a 31. I think I'm going to run out of space, so we'll extend our page. 34, 17, 26, 28, 10, 20, 14, 15, and 32. So this kind of allows me to see which frequency I have in each interval. It looks like I've got 1, 2, 3, 4, 5, 6 data points between 10 and 20. 1, 2, 3, 4, 5 data points between 20 and 30. And 1, 2, 3 data points between 30 and 40. That's going to allow me to make that histogram much easier now that I have organized the data. So here's going to be my histogram. It's not going to be anything super fancy. Up the left-hand side, you would write frequency. And on the bottom is where you're going to have your ranges. So we'll start at 0, go up to 10, then to 20, then to 30. So between 0 and 10, we didn't have any data. But between 10 and 20, we had 6. 1, 2, 3, 4, 5, 6, make a bar graph. And then between 20 and 30, we had 5. 1, 2, 3, 4, 5, make your bar. And between 30 and 40, we had 3. 1, 2, 3, make your bar. Okay, so that's about it. That's how you would take your data, make a stem and leaf plot, make a bar graph from there. The homework tonight is a worksheet, so hope you have success on it. Talk to you later. Thanks for watching the video.